Well, hi, welcome back. We are continuing our discussion of practice problem number 2. In the previous video, we kind of analyzed what the problem has going on. We analyzed the tree diagram, and we did part A. We found the probability that both spins are yellow. So now we're going to look at part B, which says find the probability that at least one of the spins is yellow. Okay, so I'm just going to give you a heads up on this. There are no pun intended here. The problem says at least. I'm going to tell you there are at least 2 different ways to solve this. I'm going to go through both ways. I'm going to go through the way that might be more apparent, and then I'm going to show you a shortcut way that you can use if you know how probabilities work and can use it to your advantage. So let's take a look. So for part B, the first thing, so let's see, I want the probability that we have at least one yellow. Okay, so the first thing that I need to make sure that I get a grip on is what does at least mean. In previous videos, way back at the very start of the probability unit, or in one of my previous videos, one of the other practice problems, I went through an example of at least. I talked about, if I tell you that you have to get at least a 70 to pass the class, what does that mean? Well, it means a 70 passes the class, so does a 75, so does an 81, so does a 97. Basically anything greater than or equal to, so at least means greater than or equal to 1 yellow. Well, okay, we got to keep in mind, how many times are we spinning this spinner again? We're only spinning it twice. So what this means, so what are the numbers that are greater than or equal to 1? Well, let's see, is 0 greater than or equal to 1? No, 0 is less than 1. How about 1? Is 1 greater than or equal to 1? Yep, 1 is equal to 1, so I could have 1 yellow. How about 2? Is 2 greater than or equal to 1? Absolutely. So I could have 2 yellows. All right, so I could have 1 yellow, or I could have 2 yellows. I did it again. Did you catch what I just did? So easy to skip over those important words. What word goes in between here? Or. I could have 1 yellow, or I could have 2 yellows. Now, conveniently, what did we find in part A? We found the probability that both of the spins are going to be yellow. So I actually can fill that part in right now. I know or means add. I know the probability of both spins being yellow, or a yellow and a yellow. I found that from part A to be 1/9. If you want to see the work on that, go back and watch the video for part A. So now I just need to deal with this 1 yellow. All right, so I'm going to use the tree diagram to help me out with this and see what are the different ways that I could get 1 yellow. Okay, so there's actually a lot of different ways. I'm going to show you kind of the long thinking through it way first. So let's see. I could spin a blue. But remember, I want 1 yellow, so if I spin a blue, the second spin has to be what? Has to be yellow. Okay, so I could have blue and yellow. Now, one of the things in the previous video, I said a lot of times people like to kind of annotate their tree diagrams. So I'm going to write over here, in order to get to this ending point, I have to have 1/6 and 1/3. So as I move across the tree diagram, I'm going to multiply because I have ants. Okay, now here's where things are going to get a little bit interesting. Okay, let me get a different color. Where's a good color? How about green? We can try green. Okay, so now let's look at this next branch. Now remember, I want 1 yellow. Okay, so let's see. I could have a yellow. Now notice, there's my 1 yellow. All right, if I go over to the second yellow, well, now I've got 2 yellows. I've already got that taken care of. I'm looking for 1 yellow. So I've already got my yellow, so where do I go from here so that that's the only yellow that I have? Well, I could go up to the blue, up here, voila. And if I'm annotating my tree diagram, I would have 1/3 times 1/6. Now, notice I also could go down to the white, because that would also give me one yellow. If I have yellow and white, how many yellows do I have? One yellow. So this would give me 1/3 times 1/2. Okay. Now, the other way that I could have one yellow is I could have a white. But remember, I need one yellow, so from here, where would I have to go? I would have to go over to yellow, and I would have 1/2 times 1/3. Okay, so all of these are ways that I can get one yellow. Okay, now, if you're really into annotating and you want to put all of this on your tree diagram, we can include the 2 yellows. I'm just going to do it in a separate color here because it's a different thing. But I could have yellow and yellow, and that would give me 1/3 times 1/3. Okay, now, from one of our previous problems, do you remember if we end up with multiple different outcomes at the edge of my tree diagram, what do I need to do with all of these outcomes? Because think about it, I could have blue and yellow, so I could have blue and yellow, or I could have yellow and blue, or I could have yellow and yellow, or I could have yellow and white, or I could have white and yellow. All right, what do we do with all of these? Or means I got to add all of these things together. So this is it's gonna look like a lot, but if you think about it, all we're really doing is multiplying and adding. We can handle multiplying and adding. We'll be okay. So I'm going to write this all out for what this looks like. So this is going to be a blue and a yellow, or a yellow and a blue, or a yellow and a white, or let's see, a white, which is what, 1/2, and a yellow, which is 1/3, or my one that I have over here, I can have a yellow and a yellow, which I already got to be 1/9, so I'm going to throw that in there. So from here, remember, this is and, or, and, or, and, or, and, or. Okay, and again, we've got blue and yellow, or yellow and blue, or yellow and white, or white and yellow, or yellow and yellow. A little bit messy, but that's what we're going to end up with. Alright, so if I do this, multiply across the top, across the bottom, I'm going to get 1/18 plus, oh, here's another 1/18 plus 1/6 plus, here's another 1/6 plus 1/9. Remember, multiply across the top, across the bottom. 1 times 1, 3 times 6. 1 times 1, 3 times 2. 1 times 1, 3 times 2. And when we do this and we add all these together, I did this a little while ago, if you add them all together and get everything to simplify, you are actually going to simplify this to 5/9. If you want to put it in decimal form, it's going to be 556. Okay? So that's kind of the long way to go about doing this. Now, there is a little bit of a shortcut that you can use if you're really good with probability. Okay? So I'm going to write this out again. I'm going to write out, let me see, I'm going to put a little line here, because I'm going to show you, sorry, a little line there. I'm going to show you a slightly different way we can do this. If you're good with this and you don't have any questions and you want to sign off right now, go for it. If you want to see the shortcut and kind of using some mathematical thinking to shorten your work, I will show you. I'm going to go through this one a little bit faster though. So I can have blue and yellow, or I can have yellow and blue, or I can have yellow and yellow, or I can have yellow and white, or I can have yellow and yellow. Now, the ones I want to look at is this group right here. These three together all came off of the one yellow branch. All right, so all of these together, they all came off of this yellow branch. Now, here's the shortcut. Remember, if I take the yellow and I go to each of these three pieces, what do all of these probabilities together have to add up to? You remember, all probabilities that share a vertex have to add up to 1. So as it turns out, what this actually is, I'm going to do a little bit of rearranging, a little bit of factoring. I'm going to actually factor out a 1/3, and I'm left with 1/6 plus 1/3 plus 1/2. These all together, we just said they add up to 1. So we can use the fact that all the probabilities from a same node or for the same vertex add up to 1. And that actually allows us to take a little bit of a shortcut, because I can lump all of these pieces together and call them, oh, hang on, I made a mistake here, didn't I? Yeah, this, sorry, that's not supposed to be 1/3 and 1/3. That's supposed to be 1/2 and 1/3. Sorry about that. My bad, because that's my white and my yellow. So I can use the fact that all these probabilities add up to 1, so that I actually don't have to do as much work. So yeah, I can leverage my my knowledge of probabilities. So either way, you're going to end up with the same answer. You're going to end up with 5/9 or 0.556, and that is the probability of getting at least one yellow. All right. Hey, give part C a try. It's actually really short. If you run into problems or want to see it worked out, join me for the next video.